this assessment, we draw the structure that corresponds with the name given. Now, this is a kind of a complicated molecule, so maybe we'll have to draw it twice. Let's see what happens. Looking first at the name, the thing we care first about is how many carbons are in the chain. So it is a dimethyl hept. So we're going to have 7 carbons in the chain, and we see that it's a 2-ene 6-ionoic acid, which means we're going to have a double bond in the molecule and we're going to have a triple bond. Our double bond will be at the 2 carbon. Our triple bond will begin at the 6 carbon. The name of the molecule ends in carboxylic acid, so we know we're going to have a carboxylic acid that represents the 1 carbon. And then we're going to have methyl groups at carbon 3 and carbon 5. And so let's get started. We'll start by drawing the carboxylic acid over here as carbon number 1. We're going to go to number 2, which we know is going to be part of a double bond. That there. That's carbon 2, carbon 3. We'll go 4, 5, 6. 6 is where the alkyne starts. And that should be the end of the molecule because we've drawn 7 carbons. 1, 2, 3, 4, 5, 6, 7. All that remains now, let's go ahead and put our numbers in. All that's going to remain now is that we put our methyl groups in. So we have a methyl group at carbon 3. We'll put that there. And a methyl group at carbon 5. I'm going to sketch this in not with stereochemistry, but we do need to come back and ensure that we've drawn the 2E and the 5R. So we have to check the stereochemistry of our double bond and then define the stereochemistry of that methyl group. Let's start with the E. Have we drawn E? Well, if we draw on the hydrogen that's here, and we prioritize the 2 groups here, this is going to be the 1 because it's a carbon attached. It's a carbon versus a hydrogen, so it would be the 1 priority. Over here, we have a carbon and a carbon. Those are equal. This carbon is attached to 1 carbon. This carbon is attached only to 3 hydrogens. So if we were prioritizing our groups, we'll use these numbers. We had 1 and 2 here. We have 1 and 2 here. The 1s are on the opposite side of the double bond. So this is, in fact, E. We've drawn the right alkene. Now, what we'll do for carbon 5 is let's go ahead and put in the hydrogen for now, just so we know, as we assign stereochemistry, we know that it's going to be the 4. So we'll call that one the 4. If we look methyl versus carbon, they're all tied based on being carbons. This carbon is attached to 1 carbon. This carbon is attached to 3 because of the phantom atoms. So it's going to be priority 1 in terms of the RS designation. This one priority 2, and this one priority 3. And so what you notice is the way this is drawn is we're going counterclockwise. And so if we're going counterclockwise and we want R, should the lowest priority substituent be coming forward or backwards? If we have counterclockwise, in order for that to be R, we want the lowest priority substituent to be coming forward. And so we know that this H should be coming forward, the methyl group should be coming back. Now, as I promised, this is a terribly complicated drawing. Let's redraw so we have the final correct answer on screen. So we're going to go up, down, all the way over to the carboxylic acid. We said that we want our methyl group to be here to make this alkene E, and we want this methyl group to be down so that and we'll still draw on the hydrogen on a wedge. So now that is the R stereochemistry. Here is the structure that corresponds to this name.